Hello folks, we've got a base station. We were planning to do something else, but a potential customer says they'd like to buy a base station, and we've got 4 Harvards kicking around. This is a 404. I've sent him photos of them all. Plug needs changing. No longer legal plug. So we'll do that. This was serviced on this channel about 11 years ago. One of the first things we did. And it's going to be checked over again. Yeah. It's got a 13 amp fuse in, that's really beneficial. So you don't see many 404s, and this is only the second H404 I've ever seen. The low serial number 0306. So we'll run it on. The customer will be getting a brand new microphone. He'll be getting a new 12 volt lead, and we're going to make sure that the power supply was rebuilt, because what we were doing 11 years ago and what we're doing now has changed. Got to make sure the power supply has been rebuilt with an upgraded filter capacitor. I'm not sure we were doing that back then, but of course time's moved on and these have got 10 years older. Whilst we've got it in bits, we'll run the lid through the dishwasher, take the bottom off anyway. Somebody's made this bottom at some time. It's not quite it isn't original, but it's pretty close to. I don't know what happened, but obviously somebody lost the real bottom, but this is a very adequate bottom, and there we go. See, that happened a long time ago. I won't bother putting that through the dishwasher. We'll be going over that with isopropyl alcohol. We weren't necessarily doing that back then. There is something rattling in this. So it's a Cybernet 002F chassis. So we need to change the filter capacitor. We need to make sure it'll do at least 3.6 watts. And that's of our watts, not good buddy watts. No, the power supply wasn't rebuilt, and so that's the first thing that's going to happen. Yeah, I can see we did the meter lamp. So what we need to do is to take out this subboard for the power supply. We're going to work on the radio in a moment off the 12 volt lead. I just want to make sure I've got the parts in stock to do this. Should have. But surprisingly, we don't get as many of the Harvard bases as I would expect. Now, because they've put the capacitor clip that way on, it makes it rather difficult to undo. I think we might have to undo the bottom ones. These don't suffer from power supply problems. We're rebuilding the power supply anyway because of the age. That's even more difficult to get to. That's going to be fun to put back together, isn't it? Difficult enough to take apart. So now we've got that, I'm tempted to put this nut and bolt the other way around. So in 40 years time, when that needs changing again, notice it's 3300, it'll be easy for somebody. Oh, I've gone by then. Right, we'll do these power supply capacitors on this subboard. Just need to make sure we know which way round these are. Well, I've got negative to the bottom, to the left. And this one. Negative to the bottom, the left. So that's 10 microfarads. And that's 47 microfarads. Right, I'll get both of those changed. Right, I've put the cases in the dishwasher, the knobs in the dishwasher. Let's plug this. This isn't one of our power leads, but we'll be including this. And get that connected up. And that's how we will run this radio. I've done the two power supply capacitors down there, the 47 and the 10 microfarad. But I thought I'd get the main part of the job done before we change that. Or is it that I don't fancy putting those screws back? Right, we need a standard Maxon, no I don't, standard Cybernet microphone. I'll go and get one. everything's moved big time. Right, we'll have to move these around. I haven't got time to faff with the cameras. So we'll switch on. Power supply on 13.8 volts, switch to DC. It's on DC. And we want channel 20. There we go. Just to show you we're on 20, it says 20. I think we'll check PA. See, back then we weren't checking PA. No idea which I've plugged into, but we'll find out. Testing 1 2, testing 1 2, testing 1 2, testing 1 2, testing 1 2 3. So it's on the volume control on these sets, not the mic gain control like it is on some sets. Just make sure these knobs are in the right position, these potentiometers, because without the actual knobs on. So we've done that. We know that's been replaced. So that's 2 ticks in the box. It's had PSU 10 microfarads, 47 mu. It's going to have 3300 at 63 volts as soon as I do that. Right, we'll go back to CB. Turn the volume down. Switch to transmit. We're on the 3 watt scale. Switch to the other power level, and we have got what? 3.6 watts. .6 watts. Channel 40. 3.6 watts. Channel 1. 3.6 watts. On low power, it's not adjustable on these, we have got 270 milliwatts, and our transmit current on full power, that was flawed, I was on the wrong channel, still the same, and what have we got? 1.31. The deviation on this test set, for what that's worth, wallow, is showing 1.5 at the moment. We'll come back to that on the other test sets. And our frequency on this test set, which is still warming up, oh, of course, all the cameras are moved, 27,79100. So it should be 27,79125. Anything over 100 is okay with me, but we'll bring it up a bit. So the meter on the front, when I key it up, is in the centre of the red zone, so it's where it should be. And it's interesting when you come back to a set that was done 11 years ago, you know, which hasn't been used in any way, just put on the shelf, and it's good to come back to one and see how it's altered in 11 years. Right, let's put the signal generator on. So I want 27,79100 to be absolutely fair. 79100. I think we've got a better SINAD meter than when I did this 11 years ago. I've got that Motorola one. They're about £800, you know, those. Right, mind you, the price doesn't make things better, does it? It just means you've been ripped off. Now, yesterday we couldn't find the trimming tool, and I got a different one out, which is a bit too wide, but I did find the other trimming tool, the correct one, and these are 1.5, and I've ordered some more from AliExpress. I think they were 43 pence each, which if you buy these from Kyocera at £15 each, I don't mind paying £5 postage from China. So I'm going to start with, we'll do the transmitter and see whether we can get anything more than the 3.6 watts, which is fine, of course. Especially with the factory original ballast resistor. Remember, these watts are my commercial watts. If you put this, if I say something's 4 watts, you put it on a hobby meter, chances are it will say 7. So I'm untuning it to retune it to find my absolute peak. So we're at the centre of the peak. Untuning it to retune it, centre of the peak. Not just a matter of, like they do at the factory, oh, it's the right number of watts, let it go. That looks right. And then the actual peaking one is this one. So that is at maximum at 3.6, but placement of some of these airspace coils could be wrong. I don't like the fact you've got to move airspace coils around, but you do. See, that's slightly in the wrong position. What else have we got? That one there. Let's get that one closed up. Wait for that to cool down. It's currently at 3.7. So I won't do the deviator. No, I won't do the power meter at this stage. What we will do is we'll do the VCO. So it's channel 1 on these radios. Especially if I can find it. There we go. So we're going to need to get an earth. It's capacitor 6, or is it 9, whatever it is, that one. We've got 2 volts exactly. So I'll need our information. Yeah, it's 2 volts on transmit, it's 2 volts on receive. You start off on receive. So between earth, I'm using a CAN as my earth, and the far side of capacitor 9 should have 2 volts. If I can manipulate these and then press transmit at the same time, we should also have 2 volts. That's very slightly high. Right, so I'll have to connect the earth because I can't kind of hold it all at once. I'll just use that can for now. So I need to key it up, put the thing on there, and adjust that trimmer capacitor. I mean, this is so close it wouldn't have mattered. But I'm going through the motions, back to receive, onto transmit, back to receive. So there we go. So that's the VCO. The last thing you want is it not working on some channels in certain temperature ranges. Right, so that's done that. Let's note that we've done that. This is something we've always done right from these being new out, or this 002F chassis, because it is critical on these. It is on the Unidens as well, but the Maxcoms, well, they don't even put all the components in. It just, well, I've had VCO problems twice in 40 years. Funny how different makes, you know, horses for courses and all that. So VCO was 2 plus 2.3. It's now 2 plus 2. So that's that. So let's look at receive. So I need to plug our SINAD meter and all the test gear into the extension speaker socket. So we'll unplug the speaker on the wall, which it's currently on, and we'll plug that in. We're going to need that earth again. We never had this problem before. We had these modern sets with the funny isolated outputs which short out when you... I'll put it on transmit coil because we're not going to be in transmit. So channel 20 is there. Make sure we're still on the frequency 2779100. Just check we're still on that frequency if I press transmit. 27. Actually, it's dropped down, but that's 5097. That's fine. So at the moment, what have we got? Let's go over to the SINAD meter and find out. And we go over to that. Of course, we're going to have to shuffle the cameras around. I wish the mice would actually reset them for me. You know, why do they get them wrong? There's trouble living in the country. Right, so at the moment it doesn't sound like, to be honest, it doesn't sound like the IF's right. Oh, that's because I was doing that transistor radio yesterday, so I've got too much deviation on. That's better. Wow, this is... I'm not saying this because we're selling it, but at the moment it's 0.21 microvolts. For 10 dB, it's 0.2. We can't. It means going to another range. So no wonder it sounded lousy. And 0.4. Squelch. Managed to turn that to full without the knob on it. Let's see where it is. 100 microvolts where we want it to be, and while we've got 100 microvolts, I'll just tell you what the meter says. It's not quite where we want it. It's being a bit generous. It's 84 microvolts for the meter, and then squelch minimum. Set squelch on the radio. Signal generator back on. Straight in at 0.3. I mean, I'm still going to alter this, even though it's absolutely incredibly good, because something might not quite be right. So we'll start by putting the oscilloscope on. Or do the detector. Is camera 3 anywhere near where it should be? Not really. 100 microvolts on the signal generator. Enough volume for a sensible trace. Detector. It's not right. The tool. Detector. Hiding under that wiring. No, wasn't quite there. So it's peak and the very slightest to the right. Now we'll do the IF. Set that for about 12 dB on the SINAD meter. I want to see it on the front panel meter as well, to make sure I can. Let's do these IFs. So I'm looking at the SINAD meter, the front panel meter and the oscilloscope. And turn the squelch off. It's there. That was slightly out. That was right. Now we'll do the front end. 4 dBs on the SINAD meter. I think that's a little too low, to be honest. Put it nearer 6. There. And there. So following that, it may not be as sensitive because the IF's now right. So let's see what we've got. The 12 dB, we've got 2.1 microvolts, which is what we had before. I mean 0.21. I'll do 20 next. 0.4. So we have made a difference, but it's still the same result. I'm just going to go to the lower scale just in case we can get a lower figure from our 10. No, it's 2. Let's get the meter set to S9. And we'll get the squelch to full on the radio, and we'll see at what point the signal comes back in. Let's go to the attenuator. If I can actually find where the attenuator's gone. The whole bank of cameras has moved. Right. 10, 30, 100 is exactly where we want it to be. The squelch is down there. We're not going to touch it if this works. So here we go to minimum squelch. Put the signal generator to standby. Oh, my fluorescent lights just failed. Straight in at 0.3, just like it was before. So it's 100 microvolts, 0.3 microvolts. But we did do some adjustments, but it's come out exactly the same. So that's good news. So I'll come back to the. I'll tell you what. We'll do the transmit. Just do the transmit. Channel 20 is where we were. Now it's cooled down a bit. I'm not even showing you the meter. I could be telling you any old malarkey. But you come here because I don't. don't tell you what you want to see, I tell you what's the truth. So, there's 5 watts on our scale, and there's 4 watts. And I'm on the blooming wrong function. It's spot on the 4. Let's go to channel 1. There's our 4. It's 4.02. Let's go to channel 40. It's spot on the 4. .02, 4 watts, 4 watts. And what has our low power become? .310 milliwatts. Current consumption, I bet it's about 1.5 now. Well, 1.335. So we've got that extra quarter of a watt, haven't we? Third of a watt, and it's gone up 20 milliamps just because of doing a retune. Now the test gear's not been on. It's only been on. I switched it on the second I sat down, so we're still not in a position to do the to see where we are with the actual frequency yet. I'll put the frequency counter up. And let's see where the frequency is at the moment. See if we can bring that up a bit. Oh, I've gone and upset the receiver, haven't I? I've adjusted the wrong one. What a wally. Now it's top of the shop, so it'll be over 100 by the time we're done. I'm going to have to reset that. Right. SINAD meter? No, that one. On to about 12 dB. And it's there. That's got that back. So we'll come back to this in about an hour. I need to go and collect the wheel for the Nissan Leaf, which just had to go into the garage because of a puncture, which is why we used the Nissan Almera yesterday, the petrol car. Just going to go through this for potential dry joints, and then when I come back we'll do the check what the frequency really is, go over this for isopropyl alcohol, all those kind of things. Right, I've done the deviation whilst we weren't recording, and that was spot on as it was at 2.2 to 2.5. So I've just taken out the 3300 microfarad capacitor at 35 volts. This is the 3300 at 63 volts we're putting in. The reason we're choosing 63 volts, whereas 35 is quite adequate, is to get it to be the same diameter so that it fits in the clip. These are capacitors we're putting in Murphy base stations these days, and these are the capacitors which we're upgrading in Uniden base stations from 2200, which I think is inadequate. So 3300 is ideal, and it's what they put. I put the clip the other way around, so the nut nut and screw of this side. So what we'll now do is to put the hardware back without the capacitor. I'll pause the video because you don't want to watch me struggle putting that in. Right, we'll cut to the chase at this bit. So I put the nuts and bolts in. Remember, I've got this the other way around, so hopefully we can get just about get the screwdriver in. There's actually a convenient notch just there that you can get the shaft of the screwdriver in. Anyway, I've tightened this one up, and I've not tightened that one up fully because it's going to compress inwards when I put the capacitor in properly. So negative is clearly labelled, so it looks to me like we're better off with the negative that way. I may as well solder them here. Okay, then we can put that in the clip, and the wires are going the way they've been naturally aligned at the factory to go. I think we'll start by using these surgical seizers or locking forceps to hold the nut. That's tight. So if I grip that, you know what, you can't grip it with those now. We'll use a locking forceps again. Of course, if I had some nut runners here, we did in the television days. Right, everything's tight. So let's see what, so we've done deviation. So it was 2.2 to 2.5, it's 2.2 to 2.5, no adjustment necessary. We need to come back to the frequency, except this hasn't been on. So we're still not going to be ready for that. We'll have a look if it's heading in the right direction. As long as it's over 100, we're okay. Well, 2779118. Let's move the camera so you can all see that. There we go. 2779118. That's absolutely fine. So we've done all the nitty gritty. Right, I'll make him up a new mic. Don't need to show you that. Take the SINAD meter out. Disconnect power from 12 volts or 13.8 volts, of what we really mean. Just disconnect that, and we'll put, this is going round and round the houses, isn't it? I do need to change the mains plug, but for now we can do that tomorrow. I want to get an on the air test done with this. Hopefully the dishwasher's finished. Did get the wheel back for the Nissan Leaf, so at least we can do an on the air test with the electric car, because you know what, even doing one test with the petrol car, having to put petrol in, yeah, it hurts. Right. Now these, unlike the Unidens, the on and off switch actually acts on the mains and the 12 volts. It's a triple pole switch. And we're also going to put a tie wrap in as a precaution, because these switches, I've seen two of them fall apart. So to stop it wanting to fall apart after 40 years, I'm going to put a tie wrap around it. There's no reason, there's nothing dodgy about it. and I'm just going to do that as a precaution. So I haven't switched this switch over. I'm hoping the power supply is running. Now we're plugged in. So plugged in and switched on, but I'm still in DC there. So I'm hoping, as I say, this is on, in which case we'll have, let's get that meter so you can see it. We should have something like 26 volts on this capacitor. Okay, we've got 19.9 volts, so that's what it runs at. So it proves that as soon as you switch this on, it's producing power, but it's not going through to the set yet, because we want to see what the output is, because it may not be 13.8. So we need to make sure that it's the right voltage. Can just take our, it might be easy to take the negative to one of these cans like we usually do for everything else. So we're getting our earth there, and then I don't know whether this is input or output, so I'm going to go onto this switch and let's see what we get. There you are, 13.89. It's absolutely fine. We'll leave it at that. And let's see if the output, we'll now switch the radio on using the switch at the back. Okay, so now we're going to check the power output. Oh, you know what, I'll drop this to 30. It's just over the top, but it's 4.2 watts. So that 13.9 might be, of course, the reason why that's happening. I think we'll measure it there. Just drop the power supply. Let's try it at 13.76, which radio will run cooler then, won't it? We're still over the top. I don't want to drop the power supply anymore, so we'll adjust the transmitter. There we go. Tidy that up, tidy that up. Check the other channels, shouldn't be any change. 4 watts on 40, 4.02, 4.05, so around there. So we are done. Right, that's it. What else have we done? I'm just going to do that tie wrap. Oh, we haven't done the meter. We haven't done the meter. So back to channel 20. And the meter preset is there. So key up. Needs to be in the centre of the red patch, which it is. So that's that done. Just check channel 9 works, yes. Pointless, of course, especially on a base, to my mind. Local farmers use 9 in this area. There's no legal requirement. I mean, in America, I think there was a legal requirement to keep channel 9 clear, but that's not something we seem to do here. So that's all ticked off. We've heard it. I've still got the lids to do, obviously. I'll turn the test equipment off because we're done. Just plug the aerial in. So that tie wrap and the lids, making sure there's nothing sharp there. There isn't. Go to channel 19. Right, well, he's walking through a storm. I'll just go and get a tie wrap and we'll put this to bed. So this is the precautionary thing, this tie wrap, and it's not easy to do. So I've just moved that capacitor slightly. I want this tie wrap to go around there. Yes, I do. In fact, we've got the bottom off. Can actually push it round. I've seen two of these fall apart over the years, so this is precautionary to just give that bit of extra mechanical rigidity. That's nice and tight. Cut that off. I think we can put the bottom on. I did the isopropyl alcohol. You know what, I think we'll put new screws in this bottom. Especially if I know where the new screws are. Okay, that's the bottom back on. Right, so there we are. Case back on, new screws throughout, and let's see if anybody's on. Helps if we turn our RF gain up. 1 and a Roger. It's tea time, they've all been called in by the mummies. $19 a Roger. That knob's not quite in the right place. Right, we'll do an on the air test. Thank you for watching the quite unusual Harvard H404 base station from around 1982 using the Cybernet 002F chassis.